Good afternoon and welcome back to AIEC Webinar Weeks. Not just bringing you products, but bringing you solution. AIEC Webinar Weeks really aims to address today's industry challenges and opportunities, along with solutions and tips on how to overcome them. Today we're going to be hearing from Verizon. Our presentation today will last roughly 45 minutes. We'll leave 10 or 15 minutes at the end for any questions. Please submit your questions to AIEC through the chat function on the Zoom platform. You'll notice a little drop-down box. You can select AIEC. Those will come directly to Brian and myself, and we will make sure to moderate those questions to our presenters today. And Brian?
Our first presenter today is Lauren Nelson. She is the Principal Architect of Emerging Technologies for Verizon in Illinois and Wisconsin. She works with cities to develop transformation strategies for economic development and innovation. Transitioning from her background in marketing and technology has given her the ability to provide unique insights into business dynamics utilizing state-of-the-art technology and infrastructure. Her goal is to help cities innovate, develop, and deliver services to help build stronger neighborhoods and communities. So with that, I'll hand it over to you, Lauren.
Good afternoon, good morning. Thanks for having me. I'm going to have Sam come on soon. He is really the domain knowledge for connected meters and what Verizon can do. And just some of the points that I wanted to hit on today are what Verizon Gridwide is it's really an infrastructure play. If you want to stop worrying or stop putting money into developing RF mesh networks or PLC networks or kind of the legacy type of networks that need routers and different type of substations and things like that. What Verizon can do for you is we provide you the network. We have put billions of dollars into our network. We have a one-to-one connection with these meters. We have different meter types that have cellular embedded chips in them, and that's what we're going to talk about here today as something either for a full deployment or for a strategic deployment. If you already have deployed AMI and you're looking for meters that are stranded or CNI meters that you want to deploy something that is cost effective, that's something where cellular may be able to fit the bill. So that's what Sam's going to talk about. If you have any questions, please let us know in the chat box. We'll be able to answer those. And with that being said, I will kick it off to Sam and let him introduce himself.
Hey, folks, appreciate the time. Yeah, my name's Sam Gregg. I'm part of our Gridwide IoT Solutions Group, specifically within what we call our utilities practice. So I'm part of the product development team. And then I work directly with the folks like Lauren as she works with direct customers. What I'm going to do today is just take about 20 or 30 minutes of your time to give you a high-level overview of what we've put together with what we call Gridwide. It's a platform as a service. So think about that as we're going through there. It's fully hosted, fully managed, what we call a platform as a service. Not another system that the utilities have to manage and maintain, as we've built this based off of open standards with pushing all the data to the existing utilities back end. So whether you're an NISC, SCDC, MB90 customer for that matter, all data flows seamlessly between the two. So keep that in mind, and we're going to just kind of give you a high-level overview. What the goal is, if there's interest, then we can definitely take a deeper dive. It really takes about 2 hours to go through the entire platform and all the value proposition across the entire utility. But I want to start off with kind of demystifying this whole network concept, because several of you, maybe all of you, have been in the situation where 3G network got sunsetted. You were forced to go and upgrade equipment, whether it be a cell phone or it be a 3G connected meter. And that is true. From 1G up through 3G, those were generational technologies. They were hardware centric, built off of different standards. And when you went from one generation to the next, it was a rip and replace. You took everything out and you put in the new. When we moved to 4G LTE, LTE standing for long-term evolution, we moved from a circuit switch network to a packet network. And 5G is an evolution of the 4G network, so it will evolve. What we're talking about today is what you hear IoT, or Internet of Things, machine-to-machine communications. The 5G standard has a component in it of what they call M, or machine communications. So that's where the 4G technology will just evolve as part of the 5G standard. Everything will be forward and backward compatible as we migrate in that. So I just want to kind of put that to rest, because it does come up with a lot of customers that deployed 3G cellular devices and had to go and physically replace those because of the sunset. Totally different technology, totally different network. Also, what we're talking about operating on today. Today, this operates on what we call our 4G LTE Cat-M network, our machine network. Much different than what you're used to with your cell phone. We actually have a lot of customers that will say, hey, I can't make a phone call at the house, but the meter works. And that's true because it's operating on a different network, on our machine network. What we've done is we have went out and we built a smart meter communications card, purpose-built for the utility space. We launched with electric metering first. We're currently getting ready to deploy our next generation module, which will also be able to support other OEM type devices, like cat bank, a reclosure, some things like that. And I'll kind of talk to that on the tail end, how we're allowing the communication there. But we've built the purpose-built card. It's got a 4G LTE Category M radio on it. And we also have an optional daughter slot on there that we can put any other radio technology on there. Today, we've got a 900 megahertz software-defined radio that we can tune that to any other device that communicates at 900. So for instance, we actually can use LARA technology, low power, long range, over 900 megahertz. We do that we've got several customers that have 2 meters. They got a separate meter for heat, sits in the basement of the house. Very hard to get any RF in there, whether it's mesh, Wi-Fi, anything. So this way, that meter in the basement can use that LARA technology, low power, to talk to that main meter outside and communicate home. Our next generation card, that optional radio slot, will have other technology on there. We can put Wi-Fi on there. We can put Wi-Sun mesh, so you can build a micro mesh downstream if you need to. It's going to also have a GPS radio on there. So we'll talk about that. And you can buy it as just the 4G LTE NIC only, or with the optional radios. But it is purpose-built. There's some things that give us a unique advantage. We worked directly with the chipset manufacturers to build this card, which means at manufacturing, we put our firmware within the baseband radio module of that card. So that is much different than any other cellular-enabled meter that is on the market today. Being that we're the carrier and we have our firmware on that card, we can now communicate to that device much differently. One, we know it's a meter versus a standard cellular-enabled meter looks like any other device out there. 2, it's operating on our machine network, and then we can provide different services down to that meter. For instance, when a last gas gets sent out, we can treat that with priority over any other traffic that's going across the network. So another thing to keep in mind, that's one of the value propositions, that as you get more and more IoT devices within the cellular network, whether that be a traffic signal, a street light, a connected car for that matter, you got to know what those devices are out there. And the way to do that is have some sort of device side client firmware sitting out there that's allowing that. And again, we're able to leverage the control channel of the cellular network with our firmware to communicate in a different way that we do not allow anybody else to do. So just high level, again, it is an IoT platform as a service. It's devices and sensors connected. Today it's meters. We're currently working with to bring water and gas on board. They were a little behind just because we needed a low power chipset that could support 20-year battery life for a cellular enabled water or gas meter. As well, we're also now working with the OEMs to put other sensors on the network. So again, I said, talk about a cat bank or a reclosure. There's some of those folks that are coming to us to say, hey, we want to enable these with the Verizon grid-wide product and with that firmware to take advantage of what that provides. And we're going to talk about what's the advantage of having a Verizon grid-wide connected meter versus a standard meter. And it rides across our 4G LTE private network, 100% private using private IP space. Our management platform is housed within the network equipment centers, the Verizon network equipment centers. They sit within the core of the wireless network. We do not allow any hosting within those facilities, so they are very secure. I tell customers those are a house with no windows or doors. There is no outside access to that. It literally is the core of the wireless network. If you're a Verizon wireless customer, hopefully you say, hey, the network is very reliable and works. You know, naturally there's problems, but for the most part, the network is there. That sits within that core, provides hardware geographical redundancy, and then we can peel that data off via any other application or API and send that data to any backend system. So whether it's NISC, SEDC, Futura, whatever you may have, we can push that data to there. That way, from a customer service standpoint, customer service folks are used to using iView, they're going to use iView tomorrow. It shouldn't matter if that's a Cannon Cooper meter or if that's a grid-wide cellular connected meter. But it is end-to-end device integration and management from the meter all the way down to the platform. Essentially, very easy to install meters. You just purchase meters and energize meters, and they will come up on the platform and be recognized, and at the same time pushed back to your backend systems. This is what the architecture looks like from a high-level overview, starting from the upper left, and we'll go right. They are connected electric, gas, or water meters. We're talking about electric today. So you've got to connected electric meters on the 4G LTE network. Goes into the Verizon, as I said, the Verizon network equipment centers. And then from there, we can take that data and we can push that data off to any back-end system. There is an option if you want to have a hosted on-prem solution. To date, we haven't had any customers that have actually done that, but there is an option if you wanted to host everything on-prem, you can do that as well. But it is very secure in terms of that data from the meter all the way back to our head end is very secure. When that smart meter communication cards gets married to the meter, we tie the IMEI, think of that as like a MAC address in the Ethernet world. We tie the IMEI to the meter ID, and then that meter ID and IMEI get tied back to our platform. And as you guys are probably well aware, a lot of these smart meters have 3 or 4 passwords in them. There is a password sync check to make sure, and then we will allow that device to come onto the network. At that point, there's essentially no need to use the optical probe any longer because that optical probe is an entry point to the network. The bad guys know that. That's how they try to infiltrate. You can use the optical probe if need be, but there's essentially nothing. You don't have to at that point. Everything can be done over the air. You can program your meters over the air. You can naturally, you're going to grab that data over there, both scheduled or in real time. And as well, we can push firmware updates out over the air. And so then you can set tamper events and alerts. You get real-time event monitoring out of this. So if you did say, hey, nobody should have to use the optical probe, if somebody did jack into the optical probe, you can get an event, an alert in real time saying, hey, why did they do that? You know, Bob was out, he was supposed to be working on something, or hey, nobody should have done that. And then down below that, we're working on an LTE IoT gateway. That'll be a standalone device that can sit on a pole, and it'll have a couple purposes. It can talk to devices in the smart home. Let's say you got a EV charger. That EV charger could also talk to the meter, but depending on what the deployment looks like, that could be a load controller, for instance. It could be talking to a cap bank or a reclosure. We're getting ready to launch that device. At the same token, that LTE gateway will also be able to, if we're in an area where cellular coverage, let's say, doesn't exist or is poor because we're in a valley, we can put this device on a pole. We can rebroadcast that signal down in the valley to pick up those devices and bring those devices back home. As I kind of said, it's a platform as a service, and so it really is an ecosystem. It will continue to grow. So as you look at this slide, you see that the big gray circle where it says grid-wide IoT platform and the smaller circles around there. We continue to add those smaller circles around there. When we launched with smart metering up there at about 1 o'clock. We're in the process of bringing on an analytics and machine learning engine. We can do distributed energy resources through that device. It is a true edge computing platform. With our technology and our communications card, we push all the logic out from the platform to the meter. So for instance, if you've got 1,000 or 20,000 meters deployed and you want to get a daily register read every night at midnight and reset max demand at midnight, we call that a policy. Think of that as a business rule. It goes and sits resident on that card. So unlike some devices that go out and pull meters for information, these meters at the stroke of midnight will go ahead, get a register read, and reset demand in that particular example, and then send that data back via the policy. At any time, we can look at those policy statistics to see which meters did or maybe did not report. And that's in a scheduled time frame. You always have the ability to do anything on demand. And one thing to note, there's no usage charges with this. You buy it you buy the service and you have full access to that as much or as little as you want. I'm going to go to like the 11 o'clock where you see managed connectivity, and then I'll talk to that utility app store. The managed connectivity that's where we're taking our next generation card and we're allowing the OEMs now to build that into their devices. You saw on the one screen, the one slide where I showed our communications card sort of looked like a half moon. We've changed the design to the next generation. It'll be more rectangular, and it's going to allow now these OEMs to go and put that into their device. That's a product we call managed connectivity. They will get all the same benefits of the security that the architecture and the platform provides, but now the OEM can put that into their device, and you may use their dashboard, for instance, to be able to control those devices. And then the utility app store, with our next generation card, we're providing dedicated space on the module at the meter for the utility or anybody to write an application to put resident onto that device. So it could be as simple as an app that you want to be able to allow the meter to talk to an EV charger in the garage, and maybe the customer is going to have access to that data. A real life example that we're working with right now is we've got several IOUs. I can't mention their names, but they're working on an FNB initiative. If you're familiar with Open FNB, Open Field Message Bus, but they've written an Open Field Message Bus broker that sits resident on the card, and now that meter can talk to any other device on that message bus that's part of that Open FNB node. So that could be a cap bank or a reclosure, whatever they may have out there. Could be something within the microgrid. The reason that's important and that's being driven is because latency becomes a big factor now whenever you're starting to look at some of those devices, especially within a microgrid. And what they found out is that while you can still have a mesh fan network, the latency is still too great. Depending on how many hops down that mesh node you are, the latency is too high. They needed to strike the latency down, to within milliseconds to be able to do that. And they needed more of a high-speed network. So that's why we had built that in there for that particular use case. That's now expanded to, it doesn't just have to be Open FNB. It can actually be any messaging bus that exists, and then we can just put a broker that exists on that bus. So something to think about. Maybe not anything you're doing now, but you want to think, hey, 2, 3, 5 years from now, a lot of things could change. I want to look at putting a system or platform in that's going to allow me to do that. I don't want to have to go back and re-architect this network, because now I need some high-speed, low-latency access for some of the applications that exist. I mean, we're probably all well aware how fast the technology is changing. So that's really, that's present today and currently and again, being tested across, at least with Open FNB. From a security standpoint, the platform is very secure. I talked about how whenever the smart meter communication cards gets married to the meter, there is an identity access that happens. In other words, we marry that IMEI to the meter ID, but the passwords that come resident on that card at manufacturing have to match the passwords that are in that meter. If they do, then we will marry those two devices together, and then they will go ahead and talk back to the platform to make sure that the platform has the same passwords as well before that device is allowed to come up and actually start to communicate. And again, if at any time, anywhere along the chain that's broken, we will treat that as a tamper event, and we will not allow that meter to communicate. You can get notification on that in real time as the end user, and then you can go and triage that. So the meter will still be up, and you may be able to speak to it, but we will not allow any access onto the network to be able to do anything. We'll treat that as a tamper. And then from the data security side, it rides across our private IP network. The SIMs are very secure. They are soldered on SIMs. They are not a removable type of SIM that I don't necessarily know. We see that too much on some of these hardened devices. But an important thing, if you are looking, you always want to make sure you're getting something that has a soldered on SIM and not a removable SIM that somebody could come and take apart. And I talked about the input and output validation where we check. There's a password check, make sure that the meter ID and the IMEI, everything matches. Then from a platform standpoint, again, it sits within the Verizon network equipment centers. So very secure. Those are monitored 24/7 by our operations center. Because again, not only are we having our metering traffic going through there, that is the core of the wireless network. So you send a text message, you make a phone call, more than if it's going through one or more of those network equipment centers that we have across the country. We've got several, and they do come in pairs, so there's always geographic redundancy across those. So it's high availability, always there, very secure. You may talk to a lot of folks that say, well, hey, we have a platform we offer as well. Where's it hosted? Well, it's hosted on Amazon. Amazon is a house with windows or doors. Yeah, it may be on the private side, but there's still a public entity to that. That's where the bad guys try to come in, and then they try to start looking and peeking and knocking on doors and windows. With ours, there is no outside access. We don't have anybody else that sits within that core except for us as Verizon. And then we do have an incident response team that monitors that as well. If there was any sort of problem or breach, they immediately can take effect. To date, our network equipment centers have not been infiltrated. So the solution is built, as you look at this slide, those 12 red boxes represent something called one M2M. It is a global machine-to-machine communication standard. Our platform is built off of that open machine-to-machine standard. So if we just start from the bottom up, essentially it's connected things. It can be, we're talking about electric meters today, but it could be a cellular-enabled vehicle charger. It could be, we have street lights, for instance, today that you could have cellular-enabled Cat M1 street lights. Then you have the network component to that. It will travel across some network, whether it be 4G, Wi-Sun, Wi-Fi, whatever it might be, 5G that's being, you hear naturally within the media today. And then as part of that, you get these common services that come as part of that one machine-to-machine standard. So device and identity security. This allows a meter to talk to another device, again, provided they're all using that global standard. So as folks build IoT devices, a question to ask is, hey, are you following some sort of standard here so that, again, 2, 3, 5 years down the road, my meter can communicate to something else? Or do I have a proprietary system based on some proprietary technology that I'm still going to be locked in to whatever that vendor does? What we've built is on open standards, and then we've adopted this open standard machine-to-machine communications that many folks, when you talk about a connected car, for instance, they want to make sure that that connected car is built off of open standards so that they could talk to a street light or a traffic signal, whether that traffic signal is in downtown San Francisco or that traffic signal is in New York. Probably two totally disparate systems in terms of how they manage them, but if they're built off of that standard machine communications, those devices now have the ability to communicate with each other in a very secure fashion. And then above that is the actual cloud hosting piece. To the right of that, where you see Verizon Private IP, that's our Verizon Network Equipment Centers and our private IP network. And again, we have the ability then to peel that data off, send it over the internet to any other device that may exist out there. But again, we'll peel that off and make that a separate connection versus the meters coming in and connecting to us to, again, ensure that there's security and we provide any infiltration across that. Now, this is the last slide I have, just talks about what are some of the use cases, what's the value proposition. From a use case standpoint, you can surgically or strategically deploy. There's no need to go and build the network. The network is there. You're leveraging the Verizon 4G LTE Category M network. So all you need to do is purchase meters and energize meters. Again, provided we have cellular coverage, but we're pretty confident we have coverage across the state, across the country. We do a coverage analysis to find out potentially where there's holes. I'm not going to say that doesn't exist. That's where we're leveraging our next generation card, where we will have LTE on that card, and you could buy that with a Wi-Sun mesh radio. And now you can have the meter build a small micro mesh. So you don't have to put a collector out there and manage that collector. Let the meter communicate and find the best way home. We have a connection manager that sits resident on those devices, and it will try to find the best connection home at any time. So you don't have to build the infrastructure. So if you've got hard to read areas, maybe you want to just deploy a prepay solution and you don't want to rip everything out you have today because you're still trying to amortize that equipment, you can just put in grid-wide enabled meters and put a prepay solution in place. End-of-line monitoring. We have a lot of customers, they'll put a meter at the beginning of the feeder, the middle of the feeder, the end of the feeder, just to get power quality data off of those meters. Again, being that the meters are 4G LTE connected, it is very deterministic in terms of where that meter is, and you're able to get near real-time access to that data. Maybe we have customers that are just using it for their high dollar commercial accounts because they want to provide, a better granular interval data to that customer. From a value proposition standpoint, you don't have to build the infrastructure. It's there. Verizon builds and maintains that. I tell customers the network will never be any worse than the first day you deploy, because we constantly are out optimizing, expanding, and growing that network. Unlike some traditional technology, RF technologies, as you deploy, things change, right? Buildings get built, trees get taller. That has an impact on the RF. From a cellular standpoint, we deal with that same problem, but we have RF engineers that their sole job is to drive around in the vehicle to find those deficiencies and then put a plan in place to accommodate for that. So if a building gets built and now downstream of that building, we've knocked cellular coverage out to 2,500 homes, they will go ahead and mitigate that, whether that's to add another cell, get higher on a tower, whatever it might be, but they are constantly doing that. So you think about whatever technology you build, you want to make sure that somebody is out there continuing to look at the RF. Who is managing the RF? Who's managing the interference? And a great example is just you think about in our daily lives from a Wi-Fi standpoint. When you go home or you go into town and you look at the number of Wi-Fi networks that are available, you're all competing for the same air. Not to mention, is it secure? So who manages that? Really nobody does, right? Anybody can go and throw up a Wi-Fi hotspot and start broadcasting. So that's where you want to just think, whether that be 900 megahertz mesh, who's going to manage that over the life cycle of the platform? Who are the RF engineers that are looking at that day to day? From a security and cyber threat, again, very secure. One is using licensed spectrum. So it's licensed spectrum by Verizon. We own it. We only allow certain things on there versus using unlicensed spectrum. So we're able to manage not just the RF and the communications portion, but the bandwidth that you get within there. Again, that's why we have this Category M network that these devices could ride. Separate slice carved out for these machines to communicate. Near real-time event monitoring. We have an event monitor that can sit resident on the card and listen for any events. Sag or swell in the network. Temperature threshold exceeded. Let's say you're getting a hot socket. You can get those events in real time. I talked to where it's over-the-air management for all meters, whether it be firmware, meter programming. meter passwords, right? Again, a lot of these smart meters have 3 or 4 passwords on them. You can now change those passwords in accordance to your IT policy, maybe every 30, 60, 90 days, whatever that may be. Believe it or not, we've got a lot of customers that we talk to that have legacy systems that have the default passwords that came from the factory. There's nothing stopping me from going on Amazon and buying an optical probe, and me going on Google and doing a search for, you know, Landis & Gyr meter programming software and find the default passwords and take a shot that the meter on the side of my house has never been changed. Not that I would do that, but that's what the bad guys are looking at, right? It is edge computing at the meter, and then again, it is reduced latency. So it's, you know, just to think not just what you need today, but think about what you're building for 2, 3, 5, 6 years down the road, other applications that may come into place. Us allowing the ability to have device communications at low latency is going to be you know, a big factor as you start to really talk about some integration between what you're doing on the SCADA side of the house and what you're doing from an AMI side of the house. And that was really the last slide I had. Again, I know it was a high-level overview. The idea here was just to kind of scratch the surface to see if there's interest in what we put together. If there is, it's a much deeper conversation in terms of we can actually sit down and show the full value proposition in terms of what's the value to engineering versus the meter techs versus customer service versus finance. For that matter, we really like to have a broad audience in that discussion because we feel that the value proposition is across all entities within the utility. And with that, I will stop and then hand it over for any questions. I'll stop sharing and we'll take any questions that you may have.
Well, Sam, thank you for that. At this time, we don't have any questions through the chat feature. I think it would be appropriate. We can go ahead and open up the floor if you'd like to comment or ask a question. Feel free to go ahead and take yourself off mute, and you can direct those questions directly to our presenter. While we're waiting for some potential questions to come in, Lauren, did you have anything you'd like to add or share with us today?
Sure. I can show a little bit about what we talked about. I think it was way earlier in the year. How do I, and I apologize, Verizon is now a Blue Jeans shop since we acquired Blue Jeans, so we're less of a Zoom shop. So I need to figure out how to show you my screen, share screen. That's simple enough, right? Okay. Let's do this. Let's do, can you see my screen?
Yes, we can. Perfect.
Okay, we had talked about this before, and we want to add value, and grid-wide is part of that. So that's something we can have further discussions about. If you want to email me or talk to me about possible, you know, just look at budgetary pricing or what it really is. If you're looking at an AMI deployment, IoT can seem complicated when you start talking about it and Googling it and researching it, but grid-wide really isn't. It's a metering program, and right now we're in Aclara and we're in Vision meters, and it's a one-to-one connection, and you can deploy. And we have some use cases to help you with that. So it's just something where we could have a conversation if you're looking to deploy AMI and possibly, you know, some of the legacy type network connections aren't going to work, or they may work and you want to do something hybrid. So that's why we wanted to bring grid-wide to you. But something else that Verizon can do is we do offer exclusive benefits for utility and government accounts. So you will get a monthly discount for being a utility, and we do have a crisis response team that can help you if you need something in a crisis. If you're looking at the special discount program, which we had talked about before, we have something called NPP Energy. It will give you a discount on your Verizon monthly plan, not the meters, but even the phones or the tablets, or if you have some routers out there, you'll get a 22% discount on those. Any plan is $34.99 or higher. So that's something you'd want to reach out to me if you want to sign up for that. It's something Verizon is offering utilities uniquely. So it's a good thing. You'll get waived activation fees. You'll get eligible for B2B quarterly promotions. And there's some custom utility plans, including some of our new push to talk, enterprise messaging, LMR type devices. Those are things that we can talk about and things that you will get a discount on. And we help utilities to move forward with it's called MPP Energy. So that's something we can sign you up for and help you with. The next thing we have is the response team, and I'll send this number out later. I think, Dan, we may have given it to you before, but I'll send it again. If something does happen and you need help, even if you need cellular help, like we can deploy cells on wheels, we can deploy trailers that will have chargers and phones for people that are in need. It's a 24/7 hotline. They can do loaner phones, they can do routers, they do cells on wheels, they have trailers. This is something that is available to utilities. So we want you to know about it. It's called the Verizon Response Team. I will send this number out. If something does happen, we want to let you know that we're here to help you. And there's a number for you to call to get a hold of them, and also, contact me and Sam, and we'll be able to get you a hold of the right person. That's the team. Most of them are, they used to be, in public safety, fellow officers, things like that, Army, Navy, veterans. So you have support, and that's the number there. This is an example of the type of devices that we've deployed. If you're looking at cells on wheels, we can do repeaters on trailers. If we can't get a cell on wheels out there fast enough or there's no fiber, we can do a repeater type situation where we can try to get a signal back up. We can do give you MiFis or give you routers to use right away, or even give you devices, one-talk devices to talk as far as phones. So there's things that we can do in any type of disaster response scenario. This is a kind of a look of what some of our deployables are. If you look at some of the routers, a couple of the phones there, that's the things that the disaster response team will be able to bring to you to help provide. I'll send this page out. It's a page for our Emergency Resource Center, and it tells you the things that we have done and can do to help you in case there is a disaster. But really, that's what I wanted to showcase to you right now with Verizon and what we can do. We have the GridWide, which is the electric utility monitoring solution. We have the NPP Energy program, which will give you a discount on your bill. And we have the Verizon Crisis Response Team, which will help you in need of a crisis. So Verizon's here for you. We do have a utility specialist, as Sam especially, and my team. So anything you need, please let us know. And if there's any more questions, I'm here to answer. But that's all I had, Dan.
Thanks, Lauren. I'm still not seeing any questions at this time. So if there's no other questions, did you guys have contact information? I don't know that I saw any contact information from you or Sam as to how our participants can get a hold of you guys should they have any questions in the future.
I do. I don't have a slide for it. Can I send that out as an email?
You can just share it here, or we should have it in case anybody wants it. If you just want to say either your email or your.
Yeah, I'm going to put it in the chat.
There you go. That'll work.
My email, and then also my phone number. But I will also send a follow-up with some of the Verizon response team information. And then if you want to dig deeper into the GridWide stuff, that's something where me and Sam would be able to have a more in-depth conversation with you, maybe show you the platform, just so you can see it and you get a chance to see what's out there as far as cellular meters are involved.
Lauren,
but I just put everything in the chat.
We had Verizon scheduled for our spring meeting this year. And we were hoping to get to demo the incident response truck, and
Yeah.
you guys had talked about maybe that's something that we can put together for our fall conference this year if we're able to have that.
Yes, and we will be able to have it. Let's do it. So think positive. It's going to be great. Everything will be open. We'll be ready to roll. But yes, anything you need from us, I will get Tony and the response team prepared. And we have a lot of stories to tell about 2020, so it shall be a good meeting.
All right, well, sounds good. Lauren and Sam, thank you so much for your time today. We really appreciate it. We look forward to hopefully seeing you in person in the future at hopefully our fall conference this year.
Yes.
So, thanks again for your presentation today.
Okay, thanks guys. Thanks for having us.
All right, up next at 2:30, we have wood pole alternatives for storm hardening. So look forward to that. Hope to see you there. If you are interested in obtaining some PE credits, that 2:30 webinar series is eligible for that. So with that concludes this webinar. Thank you very much.